So today we're going to talk about mainly points, lines, and planes, and talk about basic terms for geometry. All right, the most simple thing as far as figures go in geometry is a point. Right? We've seen points before. Specifically, we've seen them like on a graph. Right? So a point is basically just a location. Okay? A point is a location. It pinpoints a place in space or on a plane. Okay? It's just talking about a certain place. Now, a point has no size or shape. It's just a tiny little speck of a spot in space. It has no size, no shape, no dimension, nothing. Okay? Now, on our symbol sheet, I want you to go across. So the way we show a point is just a dot and a capital letter. You always use a capital letter to talk about a point. So if you see a dot and a capital letter, the letter is the name. So this is going to be point A. Okay, so it can be point C, point D, whatever other letter, but you always use a capital letter for a point. So that one, dot A, is point A. Okay? So we put that on our symbol sheet and on our notes. So that example goes with that figure. All right, like I said, any letter can dictate a point. So that's the most simple geometric figure there is a point. All right? Well, then you start seeing more than one point happen. And when you start seeing more than one point, we have other figures. Okay? So if we add one more point, we get a line. All right? So a line is made up of more than one point. So points. So a line is made up of points. Any 2 points can form a line. You can have more than 2 points on a line, but you have to have at least 2 points to make a line. Okay? You can have more than 2 points, but you have to have at least 2 points to make a line. Okay? A line has no thickness or width. So it don't matter if your line is too thick or too thin. Okay? It's just a line. Okay? You don't measure that. And this example they gave me over here, what 2 points are on the line? X and Y. Now, there's 3 letters we see for that line, right? That little letter over there, you can probably see it better on your paper, is a lowercase n. Do you see that? And also, X and Y are capitalized. So that tells you those are points. Because remember we said points had to have a capital letter. All right? So, to name a line, you can do it 2 ways. Okay? The first way you can do it is draw a line with 2 arrows on it. And then 2 capital letters of the points on the line. So X, Y. Or it could be YX. It doesn't matter the order. So that's one way we can call that line XY. Or, notice this lowercase n does not have a point that goes with it. You see that? So that means we can also call this line N. So we can call it line XY or line YX, or this one can be line N. And make sure you use a lowercase letter. Okay, so on our symbol sheet, let's do A, stick with A. A line with 2 arrows and 2 capital letters is line A, B. It's a line that contains 2 points A and B. So I just did a different example with different letters. Okay, but it has to have 2 arrows. Or if there's a separate letter that doesn't have a point, it's lowercase, you could call the line by that name. All right, something good to highlight right here is the word collinear. collinear. Okay? Underline it, circle, whatever. That's a good vocabulary term. Collinear. Well, usually you see the prefix co with some kind of word. That means they share a responsibility. Like if you've heard of co-captains on a team, right? There's a responsibility that is shared. Okay? So collinear means they share a line. Okay? So collinear points are any 2 points that are on the same line. There can be more than 2 pairs of collinear points on a line. Okay? So collinear points are any points that are on the same line. So X and Y are collinear because they're both on that same line. Okay? Non-collinear, what do you think that means? That means they're not on the same line. So that means if I have an extra point over here, a point C, well, that's not on that line that X and Y is on, is it? So those would be non-collinear. Okay? So any 2 points make a line, right? So for something to be non-collinear, that means you have to have an extra point out there that does not fall on that line, right? Because X and C can be collinear. X and Y can be collinear, but those 3 are not collinear because they're not all on the same line. Does that make sense? Okay. So what happens if we have 3 points that are not collinear? Well, that makes something called a plane. Okay? So if I have points that are non-collinear, they make up something called a plane. Okay? So the next figure we're going to talk about is a plane. A plane is just a flat surface. So that fills in that blank. That it's made up of points. So it's a flat, so you can think about your piece of paper as a plane. You can think about your desktop as a plane. You can think about my screen as a plane, or a wall, or the floor. Okay? So it's just a flat surface that has points on it. Okay, that's called a plane. Alright, it's flat. You're not talking about the depth of it, because if we were, we would be talking about something called a prism, which is a 3D object. Okay? So we're only talking about the flat surface that you see. That is called a plane. It takes 3 points to make a plane. 3 non-collinear points to make a plane. All right, a plane extends indefinitely in all directions. So lines go forever. We know that. That's why we have arrows on them, right? Lines go in all directions. So do planes. Planes can be extended in all directions. You name a plane by 3 non-collinear points. Or you see this one in the corner, this letter in the corner that doesn't have a point beside it. So we could call that whole plane plane P, and it's usually in a corner. Or we can name it by 3 points that are actual points in the plane, JKL. Or you can reverse the order, KJL or LJK. Okay, so it doesn't matter the order when you're naming a figure. It does triangles, but not these. Okay? So we can call this plane P, or we can call it plane with any of these points. But we cannot call it plane like plane JPL. Right? You're going to do the 3 points, you have to do specific points in there. So you might want to write that on your handout, that you will actually just see the word plane. That just means plane. I mean, it means what it is. Okay? So for a plane, there's no fancy symbol. It just says the word plane. So planes are plane. Ha. So coplanar, the word coplanar is just like the word collinear, except for it refers to planes instead of lines. Coplanar means points that are in the same plane. Non-coplanar means points that are not in the same plane. So that means you have to have a 4th point that's not in the same plane. Okay? So coplanar means same plane. Non-coplanar means not in the same plane. So that would be like if I had 2 different pieces of paper up here, and I had some points on this paper and some points on this paper, right? They would not be in the same plane. Does that make sense? All right. All right, so let's just talk about when these figures intersect each other. Do y'all know what the word intersect means? It means to cross. They touch each other. Okay? So when two things collide, basically. I'm going to need some examples. Maybe I can do it with this. All right, if I have two lines that intersect, let's pretend like my pencil's going on lines here. Two lines cross each other. They do it where? What does it make when two lines cross each other? A point. Now, when we were in Algebra 1, we did something called systems of equations, and we did systems of linear equations. We graphed the two lines, and they crossed at a point, right? And that point of intersection, we call that ordered pair the solution to the system. Y'all remember that? We graphed the two lines, and where they crossed was our solution to our system, okay? So two lines cross at a point, okay? And I don't want to write in yellow because we cannot see it. Okay, two lines intersect at a point. Two planes, I don't know if I can demonstrate this. Two planes intersect in a line. So you can see that picture that they gave you right there. Two planes intersect at a line. So two lines intersect at a point. Two planes intersect and make a line. So if I'm like I have a piece of paper going through another piece of paper, they make a line right there where they're intersecting. They call that line K. Y'all see that? So something they didn't show you a picture of. What if a line intersects a plane? Where do you think it intersects at? Well, let's pretend my pencil is a line. This piece of paper is a plane. This would be what that would look like. Right. So they intersect at one point. So a plane and a line intersect at a point. Does that make sense? I lost my line. So it's kind of like the pencil through a piece of paper. All right, is that all the front side? All right, y'all flip over. Getting it done today. So what we're going to do basically is just see some examples of some different pictures and some different things intersecting each other. And we're going to work on naming things and using our symbols and stuff like that for points, lines, and planes. Okay. So, number one. So, notice that this number one, these A, B, C, D, and E all goes for this figure. Y'all see that? Okay. So, all of these questions go for this figure right here. It looks like we have how many lines on here? 3 lines, and there's a bunch of points, right? Okay. So, first thing it wants us to do is name 4 collinear points. What does collinear mean? 4 points that are on the same line. Well, okay, for one thing, are R, Q, and P points? No, those are names of those lines, right? We know because they're lowercase, and they don't have a little point beside them, okay? So these, we're not going to use lowercase r, q, and p because those are names of lines. Other names of lines, they're not points. Now, it said 4 collinear points, right? Is there a line that has 4 points on it? Which one? Line R, right? Do any of the others have 4 points on them? No. So I'm going to use I, K, N, and H for my 4 collinears. Does that make sense? So just use your capital letters. I, and I'd use commas because it said 4 distinctions. K, N, and H. Make sure you use capital letters if you're talking about points. And these can be in any order. You didn't have to do them in the order I did, okay? Because they're 4 separate points. All right? Part B says a line that contains point M. Give me the name of a line that contains point M. Well, there's actually multiple correct answers. You can call it line P, line little p. Give me another name for that same line. Okay, how many points do you need to name a line? Just 2, right? If you're naming a line, you just need 2 points. So you can call it MN, and if you do it with the points, you got to put the symbol with the line with the arrow over it. I'm just naming multiple. You don't have to give me more than one if you're answering this for homework or whatever. I'm just showing you that these are all the same line, right? Right? Also OM. Okay, any of those mean the same thing. Does that make sense? But if this is a question like on a quiz or whatever, you only have to give me one answer. All right, but there's multiple correct answers. All right, C says a line that contains points H and K. So somebody give me one name of a line that contains points H and K. Line R. Give me another name for it. Line IN. So that means you would do IN with the line over it with the arrows, right? Right? And there's somebody give me one more. There's still lots of them. HK with the arrow over it. So if you use points, you have to use capital letters with the arrow over it. If you use the lowercase letter, you just say line that letter. Okay? D says just any other name for line Q. So somebody give me one more name for line Q. JK. They're not kidding. With arrow. Okay? There's only one answer to the next one. The intersection of lines P and R. 2 lines intersect at a what? At a point. So where's the point where line P and R intersect? Point N. So do your little dot, capital N. Okay? Got it? Questions? All right. Let's look at number 2. So number 2 is a plane intersecting with a line. So that's like my paper with a pencil through it, right? Looks exactly like that, except neater. Right? So this is what's going on number 2. It's a line going through a plane. Y'all see that? These dots right here is like where the line is actually where you can't see it. So it'd be like the paper tilting and you know it, the pencil is behind it, but you can't see it. Does that make sense? So that dotted part is the part you can't see, but the line is still going through underneath. All right, so it's kind of like the paper is kind of tilted at you. All right, so a plane and a line. So part A wants us to tell us a line that contains point F. What's one name of a line that contains point F? Right, F is only on one line, so you can call it line J. You can call it EF, or you could call it DF or DE or whatever, okay? Any of those. Got it? Okay? Problem B says another name for line K. Well, line K is the line that goes through the plane, right? It's the vertical line. Well, I assume it's vertical. It might not be vertical. So somebody give me another line for line K. What points are on line K? C, E, and B, right? So any configurations of 2 of those points with the arrow. So you could call it CE or BE or CB or any of those. Any configuration with line or points C, E, and B. Y'all with me? All right. What's the name of a plane containing point A? Plane M? Or you could tell me any 3 points in that plane, right? So what all points are in plane M? Right, A, E, F, and D. B is not in the plane and C is not in the plane. Y'all see that? Okay, good job. D says an example of 3 non-collinear points. So all 3 of them cannot be on the same line. 2 of them can be on the same line, but all 3 of them cannot be. So somebody give me 3 points where all 3 are not on the same line. A, E, and F. Okay? So anything like that. You couldn't do D, E, and F, right? Or B, C, and D. So somebody give me another example of 3 non-collinears. A, B, and E. Very good. Those are also non-coplanar, aren't they? right? Because B is not in the same plane as the other two. Good job. So y'all see what we're doing? And E says, what is the intersection of plane M and line K? Point E. Very good. A plane and a line intersect at a point. So any questions on number 2? Okay, y'all look at number 3. What is up with number 3? There we go. I got a pyramid here. Yep. Pyramid sitting on top of a plane. So it'd be like this. Right? Okay. Pyramid on a plane. So you know, a pyramid has different faces, right? Faces are the sides of a 3D object. So the bottom part is a plane, is a face. These are all faces. And each face is their own plane. Y'all see that? So part A wants to find 3 coplanar points. What are 3 points that are in the same plane? Z, V, and W all make that front face of that pyramid. Very good. Y'all see that? So those are coplanar. Can somebody give me another set of 3 coplanar points? V, W, X. Yes, they make that bottom face, and they're also in plane R, right? Somebody give me another one. Z, W, X makes this side of the pyramid. Very good. So if it makes its own face of the pyramid, or it's on the bottom base part of it, then they're all in the same plane, right? But like Z, V, and X would not be coplanar, would they? Because those don't make a face. Does that make sense? So I'm just going to do Z, V, and W, the first one I heard, because those are good. B says a plane containing point X. So somebody give me the name of a plane that contains point X. Plane R. That's a good one. Okay, because that's everything on the bottom. How many planes is X a part of? How many planes is X a part of? Actually 4. Okay? Because this back face with Z, Y, and X is a plane, right? This side face with Z, X, and W is a plane. The base of the pyramid with these 4 points is a plane, but that plane also extends to make plane R, doesn't it? Right? So there's actually 4. That was a good honors level question for you today. C says the intersection of plane R and plane ZVY. Well, ZVY is this side over here, right? 2 planes intersect to form a what? A line. So what's the name of the line that's the intersection of ZVY, this far side over here, and plane R? Line VY. Very good. Or YV. It doesn't matter. How many total planes appear in the figure? The pyramid has how many planes? 1, 2, 3, 4, 5, and then the bottom one. So 5 total, right? 6 total. Where'd you get 5? Front side, 2. Yeah, that's 4, 5, 6. Y'all are right. Y'all agree? How many planes contain point W? The 2 sides right here, the bottom, and the big one. So 4. I agree. Any questions there? Okay. I want y'all to try number 4 on your own. All by yourself for right now, and then you can discuss them in a minute. So try it by yourself first. Keep in mind there's more than one correct answer to some of these. So just try it on your own, and then we'll talk about it together. Now, what does it look like is going on right here? Yeah, I have two separate planes with a line going through it. So that would be like if I had two pieces of paper on my pencil, right? Right? Okay. So think about it like that. I'm going to hush and let y'all work through those four on your own. These are pretty simple. All right, if you have answered all four of them, please check them with a neighbor. Now, keep in mind, some of them might have more than one correct answer. All right, y'all ready to go over them? Let's go over them. Number 4, problem A. So like I said, we have two planes with a line that goes through both of them, and the planes are separated, right? So problem A says, what is the intersection between line L and line M? Well, two lines intersect at a what? A point. So where's the point of intersection between line L and line M? Right, you can't see my L over there. I scrolled over too fast. So my L is this line, M is in this first plane, and they intersect at what point? Point E. Raise your hand if you got point E for problem A. Any questions about that one? Number 2 or problem B says, name another name for plane Q. Well, Q is the name of the plane. It's in the bottom corner, but it's not a point, right? How many points do we need to name a plane? 3. So give me 3 points that are in plane Q. Now, is M a point? No, that's another name of that line, isn't it? So give me 3 points that are non-collinear. They can't be on the same line. So you can't use G, E, and F only, right? Because if those are all collinear. If they're in the same plane, they need to be different points scattered around. So give me 3 points that are in plane Q, somebody. I, F, and G. I, F, and G. Very good. So you'd probably want to use point I somewhere in there, right? Problem C. Are points D and E collinear or coplanar? What do you think? Collinear. They are definitely not the same plane, are they? But they are both on that line L that goes through both planes, right? So collinear. And the last one. How many times do plane P and Q intersect? 0. They do not touch each other at all, do they? They're connected through that line L. So 0. Raise your hand if you got 0 for that one. Any questions about any of those figures? All right, so that concludes the end of notes for today. Unit 1, day 1 is over.